Hello everyone, so welcome to OSTL 10. We are continuing with where we ended the other day. So if you haven't set up the lab, just watch the lab setup, on YouTube. Also, you remember basic ICT input device and output device. Our focus here is on the output device. You realize that we said output device are device that bring out information to the world or display information to the user. It's in the same way in programming. When we are programming, we want to bring out information for the user to see. In the programming language, we have something called output stream. So this is actually a function which actually display information to the user. So because it's very common to be printing stuff when you are programming, by default, the language designers actually implement this library for us to use. So in C++, we find this library, this IO stream or the output stream in the IO stream. And in C++, if we want to display something on the terminal, we use the cout, st.cout. This is actually telling, okay, this cout is in the standard namespace std. And also, remember C++ is evolved from C. So in a language like C, you'll be using printf, which is actually found in there, what's a library called std.io. And because the C++ compiler is backward compatible, you can still use them. So this is how we print. If maybe you don't want to always be using std dot the scope resolution operator, you can just say using names with std, then you can always use the cout just like that. Okay. So the important thing here is the difference between using C++, output stream is because they are type states. They are very safe, they are less error prone, and also you can extend it to your own use, and also it's very performant compared to the printf in C. But as over the years, C++ has evolved, and in now C++ 2023, we can easily use the Python flavor like that print. So we can easily use a library called print, which is here. And we can use st.print, which is very readable. Hello world, to print whatever we want. Okay, so now let's actually try our hands on. If you go to the course website and we click on here, we can easily see some of the code here. Some of the lesson, and we go to the lesson, you can see the source code, and we can easily copy and paste it in the test editor in the virtual machine and just compile it. So one thing I want us to look at is I want us to log into one of the virtual machines. So I will come here. If you haven't registered a virtual machine, just watch the video and just register it. So I'll come here, then I'll come and log into one of the remote machine. Because I've already registered I'll just log in with my details. Then I'll just log in here. Then what I'll do is I'll join a queue. Then I'll select, make sure that you select Kali, then it's 2024, because it's come with the latest C++ compiler. Then I'll just switch it on here. Then I'll wait for it to boot. Then what I'll do is I'll come back to CPP, or you can click here to lectures and lab. Then you click on the lesson here, then you get the lesson 1 source code. So when I come here, wait for it to boot, then we just log in. So after let's finish booting, we go to connect. Okay, it's still now on its own. So after it's being connected, now we go to SSH. So in the SSH section, what we do is our username is by default Kali, and our password is also Kali, Kali. Then what I'll do is I'll just log into OSCL. There's a simple listing. Then what I will do is I'll make a directory called lesson. I'll make a directory called example x1. Example. Let me do it lesson 1. So make it organized. So I'll do lesson 1. Now I'll log into lesson 1. So all what I'll do is I'll be using the node test editor and I'll say, okay, example 1.cpp. Then what I'll do is I'll just copy one of this. I'll come to the source code and I'll just copy, using the C++ on version. So you can try all this stuff. But the important thing is using the main C++. For C++, we can just use any of this. So let's use this one here. Now come here, then I'll just click here, then paste it. Then I will save it. I'll press Ctrl S and save it. So what I will do is I'll just compile it using clang ++. Then I will say, okay, the version I'm using is std. For this one, we can decide not to use any version. I will say, okay, let's use any version at all, or you can decide to not use any version. So maybe C++ 11. Then okay, I'll say example -o in example 1. So realize that it has compiled. So now we can just run it, example 1 here, and say let's print this thing out. So now let's come back. Realize over the years we can easily do the same thing using the printf, which is very nice. But this printf is only compatible with latest compiler, which supports the C++ Unitary standard. So let me do, we're using nano example 2.cpp. Then I'll click here, paste, then I'll print Ctrl X and save it. But one thing about this, let's try and use G++ here, the GNU compiler, and let's try and compile it just like that. So realize there's an error, and even let's use a clang and just try and compile it. It's also an error because by default clang is just using maybe C++ 11 standard, and the print function is not it's not available in C++ 11. So that's the compiler is showing the error. You can figure that one out. So the only way you can make it work is using C++ by specifying. If you are using GNU, you say, okay, std, you are using the standard version C++ 23. Then I can use example 2.cpp. Then okay, I want my output to be x2. And even the GNU is, so now let's try and use the clang. The GNU shouldn't complain. So now let's use clang. So realize that, sorry, supposed to be clang ++. So with a clang, so there's a mistake. So I made a mistake. It's supposed to be std, so that's where the mistake is coming from. So realize I want to read that it works, right? Because because the printf is only found in the C++ entry standard. And in the same way, we can do the same thing with clang. And clang will compile fine as like that. So we made a mistake here. So what we are doing, okay, we are using a clang compiler, and the standard version we want to use is C++ entry standard version, and it's also do the same thing. There is no error, so we can just compile it. So this is just a preparation and overview. The important thing I want us to understand is C++ has evolved, and this C++ focus on modern C++. And for modern C++, I realized that some of the features in C++ 23 or the C++ 26 standard or C++ 20 cannot be compatible with older compiler, or we can compile like most of the C++ 23 features with C++ 11 compiler. So this course is all about, understanding and also being able to write, modern C++. So thank you, and we are going to start next week with the basic C++ and build up to advanced C++. So if you haven't set up the lab, make sure you watch the first video on YouTube to set up the lab, and so that we can all cope together when we start next week class. So thank you, and bye bye.